Alright, so this lesson is called Building an Atmospheric Reentry Capsule, and it's going to be in our Earth Science unit here, and it's covering standards 8.4.1. Students will investigate and describe the Earth and the solar system, and 8.4.2, students will investigate and describe the Earth's structure, systems, and processes. And this is basically going to be our first lesson in Earth Science, and the goal is here to get kids thinking about the Earth's atmosphere in a kind of an engaging way. And so what we'll be talking about is space travel, and talking mostly about how when a space shuttle re-enters the atmosphere, it actually runs into the air particles that make up the atmosphere, the different gases, and that actually is what helps the spacecraft to slow down. Now, what we'll get into is the different densities of the atmosphere as you get farther and farther away from Earth, because as we know, right, gravity pulls everything towards the center of the Earth, and that includes air molecules. And so as you get down closer to the Earth's surface, there's going to be a denser pack of air molecules. We know that from going into the mountains and the air being lighter up there, as people would say. And so there's actually fewer air molecules the farther you get away from sea level. So that'll be important to help kids think about, is as you get farther and farther and farther into the Earth's atmosphere, away from the Earth, there's fewer and fewer and fewer air molecules to bump into, because there's fewer of them around. The air is less dense. And so density is a really important term for this lesson. That's maybe a term that some of the students aren't familiar with. And so we'll do a little demonstration with oil, water, and rubbing alcohol that will kind of show the differences in density. And we'll use that density column then to think about the Earth's atmosphere. In the density column, and what I like to do with that is just to show kids the difference in density, is I start with some water and put a little food coloring in it. So I'm just going to drop a few drops of blue in there, and I add some water, to this bottle. So dump the water in here, because like I said at first, I don't think density is something that 6th graders, in this case, or the age that I'm working with, are extremely familiar with. So we've got our blue water in here. Then what I like to do is add some oil, and I ask, where's this oil going to go? To the bottom? Is it going to stay on the top? Is it going to mix? And most kids do know that the oil will float on the water, so add a little rubbing or cooking oil, and you get, so you get this. You get the blue with the oil on top. And then I ask them what will happen if I add rubbing alcohol, 91% isopropyl rubbing alcohol, and then that's where kids are a bit confused. So they aren't sure exactly what's going to happen. So I might add a little bit of rubbing alcohol, or a little food coloring to this rubbing alcohol also, so we can kind of see where it goes. Turn it green, and just kind of have to slowly pour this in here. And it should, if you pour it slowly so it doesn't get down and mix with the water, it should go right to the top. Okay. So this is a good example of a density column. Now clearly there is more than just density involved here, right? The fact that they stay separated has a lot to do, or has everything to do with the fact that oil doesn't mix with water or rubbing alcohol because of the differences in polarity. But you can see here now, you can show the kids that this is 3 liquids, and all of them have a different density. Water at the bottom is the most dense. Oil in the middle has the density between water and rubbing alcohol, and rubbing alcohol on the top is obviously the least dense. Okay, it's on top. And so that helps kids think about a little bit about density. And then I always like to ask the question, if I had a gallon of each of these liquids, which one would weigh the most? And of course water would weigh the most, and rubbing alcohol would weigh the least, and the oil would be in the middle. So that's a good way to relate, density to mass. Thinking about how much you have. If you have equal amounts of 3 things and they have different densities, then the most dense one is going to weigh the most. And so if you have trouble understanding density and don't know how to maybe explain it to your students in the easiest way, I think that it is a difficult one because students want to think of it as weight or mass, but what you have to think about is that density is actually a measure of how much of mass you have in a given area. So you can think of a bowling ball being very dense, 10 pounds in a very small area, compared to say 10 pounds of feathers that may take up a much greater area. So you'd have the same mass, right? They weigh the same amount. There's 10 pounds of feather weighs the same as a 10-pound bowling ball, but there's a big difference in the density. All right, so I'm going to swing the camera around and show you the setup for this one. What students are actually going to be doing is trying to build an atmospheric re-entry capsule, basically a capsule out of tinfoil that's going to protect their astronaut, which is an ice cube, from melting as it re-enters the atmosphere. And since we obviously aren't going to be able to have an atmospheric re-entry, we're going to be using candles to provide our heat source. If you have access to a Bunsen burner, that's even better. But if you're in a classroom without it, candles will work fine. That's going to provide our heat. And because as that space shuttle hits those molecules and slows down, it's also going to create a lot of friction, which results in a substantial amount of heat. So let me swing the camera around and show you kind of what students might come up with. Okay, so here's kind of the setup for this. I bought this as like a plaster ring that you can get at a hardware store. And I've just got 6 votive candles. And I turn 4 of them upside down and then set this on top of those. And these candles are going to get lit. And the students get, I usually give them something like about a 6 by, maybe 6, or maybe this might be 8 by 6 piece of foil. And they have to use that to come up with their capsule design. And the rules are that the capsule has to sit on top of the testing apparatus here, and it has to contain any water that might spill out. So if any water spills on the candles or the table, then at that point we'll stop their time. The goal here is to have your ice cube last as long as possible. So we'll just light these candles. All right. And the trick is keeping these things lit, really, during the activity. So we'll get them lit. We'll let them burn a little bit. And I made mine like kind of a hollow tube, thinking that the air would insulate the ice cube. So we'll set that right on top there. Okay. And then the ice cube goes on here. Okay. Obviously things are going to get hot pretty quickly, so we've got to make sure students keep their hands out of the way. And these take quite a while when you're dealing with candles. If you have a Bunsen burner, you can do this activity a lot quicker. But with candles, you're going to want to have one of these setups for every group of student. Otherwise, it's going to just the activity will just take too long. So that's the idea. You let the ice cubes melt, you time them, and you see whose ice cube is going to last the longest. And then you can kind of talk about the comparisons between different space capsule designs. So that's it for the atmospheric re-entry capsule. It takes quite a while for the ice cubes to melt, and it gives us a chance while they're doing that to really continue to talk about the Earth's atmosphere. And that's going to be really important over the next several lessons. The next lesson is called Warming Up, and we're going to be talking about how the greenhouse effect, which is a fundamental part of the Earth's climate, and it's a good thing. Without the greenhouse effect, the Earth would be uninhabitable. We're going to talk about how the atmosphere plays a huge role in the greenhouse effect, and how when we start to add different kinds of gases to the atmosphere, we can have a dramatic effect on the climate of the Earth. So this is a good way to start thinking about the climate, or thinking about the atmosphere of the Earth, and we'll use this information next time when we do our warming up lesson. So extensions of this would be to research the atmospheres of other planets, would be a really good thing, and that would also be a good lead into next week's lesson. How do other planets' atmospheres or lack of atmospheres affect the climate on those planets? And another really interesting thing to research would just be space travel over time. It's really fascinating, and I think it's recent history, but for these students, it's something that might be pretty interesting for them to know how far we've come in just the last 50 years when it comes to space travel. So that's it for this week. I'll see you next time.